Okay, so now we will start with the third stage. So it is same as second stage. The process is same as we did in the second stage. So you just have to observe this carefully. Okay, so here in this third stage we have pasted we have created these three parts, and here we need to create one axis, and here we have to just constrain this axis system. With this third stage axis system, like this. Okay, so now what we have to do, we have created this pilot bush. So similar to second stage, so in the same way we have to do the same thing for the third stage. So we have to give the constraints to the pilot bush. So first we have to copy this notch, and we have to extract this first, and then we have to publish it so that we can copy and paste it with link. So this operation we have to perform, this cutting operation we have to perform. So we will rename this as stage 3 notch. Okay, so now we have to publish this, and after publishing we have to copy this and paste it inside the third stage part. Now we have to take this pilot pie okay, so this third and fourth, we have already published these two axis systems. And we have to paste it as a result with link inside this part. So this is for the pilot piercing. This is the position of the pilot piercing at the third stage. So as you have observed, or you have seen, that we are keeping link everywhere, so that only the original parent, if we modify, everything else will change according to the parent. All the childrens will get updated automatically. So this is the benefit of using publication and keeping link with each other. So this is the best CAD methodology. So as you can see, in this way we have created pilot bush at the lower side. So now we have to create the notch still for this third stage, because there is no standard part for that. We have to design it on our own. So here we will rename this body as third stage still we have to create the solid body here. For the cutting operation, so for that we have to create a sketch like this, and here we have to consider that published reference element. So here we have to create one rectangle, and we will give the dimensions. So here we will take symmetrical. So there should be sufficient space also for the springs, so we have to keep sufficient space. Okay, so we have created pad of 40 mm. So we have to consider the size of that block as per market availability, and now we will create a same sketch, and here now we have to consider this profile, and I will offset it at 0 mm, or we will keep clearance here. So we have taken 6% of sheet thickness. So here we will offset this by 0.15, which is the 6% of the sheet thickness. So we have given the relief and we have kept the sufficient lined, as you can see. Okay, so now here in this sketch I will create one rectangle like this, and we just want these 4 points, and then we can give the proper dimensions. Okay, so 2 dowels are sufficient because there is no load on this block, so 2 dowels are sufficient. And here we will give the threaded bolt first. And now we will use a pattern this. Okay, so here we have created 2 screws. So let's rename this sketch as screw. Now we have to create the dowels, so for that we will use the same sketch instead of creating another sketch. and here we will rename this as dowel. Now we have to edit this sketch, and instead of these these 2 points, we want these 2 points now for the dowel. So there is no need of counter, but it is recommended to give, otherwise the height will increase unnecessarily. So that's why we have given the counter diameter to the dowel. Okay, so now we will first save all this by using save management. Okay, so now I will copy this and I will break link and I will paste it here. So this is for the fourth stage actually. So let's rename this as stage 4. So now we have to create the lower elements for the stage 4, and here we will create one more part, and I will reorder this first. So here we have to create the steel for the fourth stage. So first thing we have to do is create the axis system. So again the process is same, so just observe this carefully. Okay, so now we have to take the pilot axis systems. Okay, so now I will give the constraints. Okay, so now this is done. Now we have to create these trim lines or these cutting operations. We have to extract this for the fourth stage. So let's extract these boundaries for the cutting operation. Okay, so we have extracted this, and okay, so before that we have to rename this similar to the third stage. We have to rename this for the fourth stage, and then we will publish it, and we will use this published element in the fourth stage. Okay, so now let's see what we can do now. So in this stage there is no need for the piloting. So we will check the axis of the third stage for the piloting first. Okay, so here what we will do, we need to take this 20 mm below. So here we will create one line in the Z component of 20 mm, and then we will, instead of this point, we will use this point. I think this line is not correct, so the direction should be so here we have to give this direction. Okay, so now it is correct. So in the same way we have to do the same thing for the other axis system also. So we are basically shifting this by 20 mm in downward direction. So now we will first update all this. Now you can see the bush are now 20 mm below, because in this stage it is very near to the cutting operation. So that's why in the fourth stage we are not using the pilot piercing, so we will delete that. Why we are not using pilot piercing in the fourth stage? Because it is very near to the cutting operation. Okay, so first we will create the steel for this fourth stage. So let's suppose at that area there is rework. If we there will be a rework, in case of the rework in that area, we need to change the whole insert. So instead of that we will create separate insert for this, so that only we can change that area only. Okay, so now we will copy this sketch and paste it again. Okay, so now we have to offset this by 0 mm, or we have to keep the clearance, which is 6% of the sheet thickness. Similarly for this one also. So here we have kept the same insert only, and now we have to pocket this up to next, and then we will give the machining color. So here we will give 2 mm in this sketch in the opposite direction, like this. So this is for the relief. We have to give the relief of 2 mm and 10 mm lined between 8 to 15 mm. Now we have to do the screwing operation on this. Okay, so we need only corner points. So 2 for the screwing and 2 for doveling. So basically we have to split this insert. We are not keeping the same insert, we are not keeping the single insert, because the reason I have already told you. Suppose at one area we get a rework, then instead of replacing the entire insert, we can only replace one insert. So that's why we are going to split this insert in 2 parts. Okay, so here we will create the holes of counterboard holes of diameter as per the diameter. We have to keep the counter bore diameter, and the screwing is done. So this is very close, so here we will increase the distance a little bit. Okay, so let's rename this sketch as screw, and now we will copy this and paste it for the dowel. Okay, so instead of that we have created screw on the other side, and now on the remaining 2 points we will create the dowels. 8 mm diameter we have to keep for the dowels also. Now we are done with stage 4 still. Okay, so here we will add one parting line so that we can split this still in 2 parts. Okay, so in this way we have splitted this in 2 parts. So for the 4th stage piloting is not required. Okay, so the 4th stage is done. Now we have to add the punches for the 3rd and 4th stage, similar to the 1st and 2nd stage. Okay, so similar to stage 2 and stage 1, we have to add the punches and punch holder for the stage 3 and 4. So there is only punch in the 3rd stage and 4th stage, so there is no need to create the product. Okay, so let's see. We will add the axis in the third stage first, and then we will give the constraint to this first. So there is only one part, so we have not created a product, we have inserted a new part only. So first we will constrain this with the third axis, which we have created already for the third stage. Okay, so we will copy the sketch, we will copy the published element from the third stage, and we will paste it inside this part. And now we will create the body, because we have to create a punch, and for this operation there is no standard punch, so we have to design the punch as per the cutting profile. So let's create the sketch on this plane. Now we have to take the profile of this punch, and we will keep nominal size only without any tolerance. So wire cut operation can be done for this punch. And at the bottom we will give the screwing. So here only one screw is sufficient. So here we will create one point, and at this point we will create one screw of M8. And we have to keep the V bottom. Okay, so we have created the screw. Okay, so similar to this. Okay, so here we have to also consider 3 mm entry also. Now we have to create the punch holder in the same part. So here we are seeing where we have to do the VMC and wire cutting, where we want accuracy, that at that position for that part we do wire cutting, where accuracy is required. Okay, so let's rename this as stage 3 punch holder. And here we will create a profile for the punch holder. Okay, so now this is done. Now we have to create the profile of the punch here also. And here we have to keep the 0.01 clearance as per the fitment H7G6. So according to that we have to add the clearance. Okay, so now we will add the punch back plate now for the stage 3. Okay, so here we have to give the constraint to this by 0 0. And here in the sketch only we will add the chamfer. Okay, so now we will add the screw at the bottom of countersunk type. And we will select depth and diameter type. Okay, so in this way we have created the hole on the punch back plate. So also we have to check the availability of that. Okay, so we just reverse the direction. And now it is correct. Now here we will add the screw on the punch holder. So we have to create a sketch on this face. So we will rename this as dowel. And we have to give the counter bore diameter. So similar to this, we will add dowels also. So here also we need to add the color. Okay, so stage 3 is done as per previous stages. So stage 3 is done completely, and now we have to do the same thing for the stage 4. So before that we will save this. So here we will copy this and paste it. For the stage 4 we have to rename this also. So here also we will add the access system. So the process is same as stage 3. Okay, so here we have to create the punch holder and back plate. So similar to the stage 3, we have to copy the notch and paste it inside the stage 4. Okay, so here we have to copy this stage 4 notch and we have to paste it inside this part as result with link. Okay, so here we have to rename this body as stage 4 upper punch. Okay, so we have to create two individual punch, and we have to keep the nominal size, and we have to keep 3 entry as well. So this will be also wire cutting will be done, so that's why we have to give the wire cutting color for that. And at this position we have to add the screw, because this is symmetrical, so we will keep this symmetrical only. Okay, so in the same way we have to do all the operations for the stage 4 also. Okay, so this punch holder we can keep common. We can keep this common punch holder. So if any damage happens, we can only replace the punch. So as per H7 fitment, we have to give the clearance. Okay, so we have to create the holes for the screwing. So with respect to these edges, we have to give the dimension. Okay, so here we will make 150. And we will add the counter bore. And then we will use a pattern this. And we will rename this sketch as screw for the screw. Okay, so now we have to rename this as dowel. Okay, now we are done with screwing and doweling. So here we have created one body, and we will rename this body by this name for the stage 4. Okay, so for the back plate we will use the same sketch. Now we have to create the back plate. And here we will make it 0 0. And we will give the chamfer in the sketch only. So here we will do the countersunk bolting at the bottom of this back plate. And then we will use a pattern this. Okay, so in this way we have created the back plate for the 4th stage. And now we will give the relief. Okay, so now we will give the apply the color. Now we are also done with stage 4. So we are done with stage 1, 2, 3 and 4, as you can see. Now we will see by taking section cuts. So before that we have to save this first. So as you can see, we have taken 3 mm entry at every stage. So that is what we have to check. Now we have to add the pilot punch. Okay, so in the 4th stage we have not used pilot. Okay, so now we will proceed towards 5th stage, which is idle. So in the 6th stage we have to do the forming operation. 5th stage is idle, and in 7th stage there is a piercing operation. So we will see all these things in the next